My name is Patrick Hanley, Marketing Manager with our touch group. I'm going to present to you about our button sliders and wheels, BSW as we call it, particularly our haptics. So we press released this week and a half ago, so it was Wednesday. Going through what I'll talk to you about, some success stories that we've had, some success stories that we've had, then I'll go through the touch solutions that we currently have to offer you. And then get into the details on what haptics, what they are, how they're used, where our first product release that we've actually had, and then get into a little bit more of the details on how you actually go about designing with haptics, both from a mechanical and electrical standpoint, as well as the components required to make it successful. So, over the span of the last year and a half or so, BSW has been very successful in a variety of different industries. We've got 3 selected on here that we're showing, but in general it's absolutely not limited to just these 3 industries. But we've definitely seen a lot of takeoff recently in the home appliance market. What we've concluded is our old tagline is absolutely accurate: where there's a button, there's an opportunity. So we believe today that anywhere that there's an electronic device, you have to have some sort of user interface to it. And our mission is really to try and help improve that user experience, making that interaction better. So touch solutions that we offer today, we've got our Q-Touch solutions, which is our application-specific devices. This is our quickest to market, no programming required. You buy it, you tune it, and you're able to operate your capacitive sensing technology. Then we've got our Q-Touch library. So this is our standard touch IP on over 80% of our MCUs. Included in that is our ARM, AVR, UC3. So it's not limited to just one or the other there. And then touchscreens, which has been very successful over the past 2 years or so. Our Max Touch technology has really taken off. In general, this is the same charge transfer technology that enables the same capacitive sensing to work, and it's really about the sensors that really make the differences here. So haptics. Most common complaint I've gotten about capacitive sensing technology in general has always been, how do I know my finger press has been accepted? Historically, solutions included, you had a light that could light up, so an LED. You'd have some sort of sound or audio feedback. But what we're offering today is tactile feedback, so a physical response or haptics. So that's just a vibration that's created. And the way we're creating that vibration is through a small ERM or motor or actuator. So the way we've gone about doing this is we partnered with the market leader in haptic technology in a company called Immersion Corporation. They're located here in San Jose as well. And we've done a license program agreement with them, and we've got 14 different effects that we actually offer on our first device. So going back to where we see touch technology capable of being successful, everywhere. And that's absolutely applicable with haptics as well. Anytime you want to have some sort of tactile feedback included with that capacitive sensing technology, haptics is a great option for that. So the 2 reasons why we've really seen customers come, hey, we really want to get some sort of tactile response, both the emotional and the functional. If you go through the different ones, gaming, think of like your Sony PlayStation controllers. Tiger Woods, you know, you're setting up for that big putt, and you know it's 80 feet long and it's to win the Masters, and you come back and you're feeling your heart pumping in the controller. That's really a haptic response. So that's the same concept as what we're offering today. And so from a gaming perspective, you're able to see the game, you're able to hear the game, and now you're able to actually feel the game as well. So it just adds an extra sense. With mobile, it gives you that mechanical feel back. So instead of, once again, having to wait for a response on a screen or see some sort of reaction based on how my my finger press has gone on, I'm able to actually feel it. So it just restores confidence in my fingers from a user's perspective. And then home appliance, the same concept there as mobile, except for we've seen in home appliances very large buttons counts. And with the larger button counts, having the ability to have different custom effects. So I can have this section feel this way and this section feel a different way. It just adds the overall user experience. From a functional standpoint, the industrial space, and really all of these, it's situations where as the user I need to be able to look at something else and be able to manipulate my control panel at the same time. So if I'm watching a production line and I need to adjust the speed of the production line or some other action, maybe stop it, I need to be able to feel where that's at instead of having to actually turn over here and then turn back. And it's been one of the big blockers into capacitive sensing technology really taking off in the industrial space. So we're able to restore that mechanical feel with haptics. Automotive, same concept. I need to be able to focus on the road while I'm driving. I still want to be able to change the defrost or turn up the heat, change the radio. I can feel where those are at versus having to actually look at it. And then medical, same concept. Once again, I need to be able to focus on my patient as I'm the surgeon or the nurse and still be able to make adjustments. You're able to feel that. So our device that we press released a week and a half ago, as I said, is our AT42QT1085. It's an 8-button capacitive sensing device that has those 14 different haptic effects that I mentioned. So we've got data sheets going to be out very shortly. It should be available on the website, the summary this week. Eval kits are going to be available about middle of the month. Samples are available under NDA today to customers, and we expect full production by the middle of the month. So overall, haptic topology, just to kind of give you a high-level overview on how this works. So as I'm the user, I touch the button that I'm trying to push. That signal actually goes from the sensor to our device. So this is our QT1085. That is then communicated to the host processor. So if maybe that's an on-off button or a volume button, whatever functionality it's driving, it goes to do that functionality from the host processor. But at the same time that it communicates to the host processor to go execute on whatever functionality, it also communicates to the amplifier, which then in turn drives the ERM. And so that's what gives you that haptic response. And this all has to happen instantaneously, otherwise it's kind of pointless to have that response. If it happens a couple seconds later, I've already pushed that button 3 times because I'm mad it hasn't happened. So from a design standpoint, there's a couple other considerations that have to go into doing haptic technology. You need to consider the mechanical aspect of it as well. So when you're doing the design, it depends really if you're going to have a handheld design or if it's going to be something that's going to be docked on how you want it to interact. From a handheld standpoint, you need to be able to get, you want to be able to feel it in your hand as well as your finger press. So usually you'd hold it with one hand and push with the other. So I want to be able to feel that vibration both in my left hand in that situation as well as my right where I'm actually pushing on the button. To do that, recommend that you put the actuator at the end where your hand would most likely be located at, and you'll get that feeling both in the hand as well as in the finger. From a docked standpoint, so this is, let's say you've got a thermostat on the wall, so it's never going to be like resting in my hand, but I need to be able to feel that when I'm pressing on it. What's most important here is that you're getting consistent feedback or vibration across the entire touch surface. The best way to do that is make sure that you're getting on the actual XY intersection points of the device itself. So first priority recommendation is dead center, so you're crossing both the center points of the X and the Y, the vertical and the horizontal. Second is either the top and the bottom here, but notice how your ERM is still right on that horizontal line. And then the third would be off to more of the side, but once again, the actuator is still right on that vertical line. As I said, this is going to give you your best because it's getting both. So components that are necessary, the actuator. So we talked about where you'd physically lay it out, but you've got to select the proper actuator. And variables that you've got to consider when you're making that decision, the size of the device or the mass of the device that you're trying to vibrate, the weight, the mass, the size of it, also the voltage that you have available to you, as well as the mounting location that you end up selecting for your actuator. And then depending on these variables, we've got a couple recommended actuators here. The Sanyo is recommended for the smaller devices, so somewhere below 150 grams, that would be the recommended actuator. Whereas the Jinlong, it's recommended if you're going upwards of like 200 grams for your overall device. And if you're working with a product at the end of the day that weighs more than that, we recommend you work directly with us, and we'll help make some recommendations on what will probably be the best feel for you. So another component that's necessary and consideration on the electrical side of things is an amplifier. The things you need to consider with the amplifiers, you need to be able to have the two that we recommend is this one and the next one I'll talk to. They both are bipolar, so you can actually drive the actuator either forwards or backwards, which is necessary to get both the custom effects that I talked about as well as that instantaneous response. And they both have the ability to be you can overdrive them. And so that once again enables that instantaneous response that is absolutely imperative to getting a good haptic feedback. So the TPA 6205 and also the DRV 8601 are the two recommended amplifiers that we have available, or that we're recommending. And then if you want to go and kind of compare, okay, which one's going to be best for my particular design? Well, it depends on package, so size that you've got, room you've got available, as well. So as you can see, we've got different package sizes, and then also shutdown currents. So if you're really working on a power-sensitive device, the DRV 8601 is probably going to be the better device for you. So overall, that is how haptics is implemented. And going into a quick summary here, Atmel is absolutely the touch leader. Our charge transfer technology has made both our BSW successful as well as our touchscreen successful. We've got the best MCU core in the industry with our AVR, our ARM, as well as our UC3. And then we've got a broad portfolio. So being able to implement both the application-specific devices as well as the Q-Touch library really sets us apart, where you can get a particular device for your particular need. And then revolutionary new features, so one of which that I talked about today is haptics. We're absolutely one of the first people in the industry to be able to offer you capacitive sensing with this tactile feedback.